Hi, I was just going to show you some ways that we teach multiplication. We have several different representations, and I'm just going to go over them really quickly, just so that you're aware of what you might be seeing coming home on your students' work. So when we talk about multiplication in third grade, we are not seeing it the way that you might be used to seeing it when you learned. What we see is we will see the number sentence. So for example, 5 times 4 equals question mark. And we know this is 5 groups of 4. They know that the multiplication sign can be interchanged for the words groups of. We talked about that at the beginning of the year when we were talking about expanded notation for place value. So the way that we could do this is we could say that there are going to be 5 groups of the number 4. So I could say 4 plus 4 plus 4 plus 4 plus 4. Because multiplication is essentially repeated addition of equal groups. That's the big thing that we're trying to work with them on, is to make sure that they know that they have to be equal groups. So saying it's repeated addition does not necessarily help, because you can't say 1 plus 2 plus 3 plus 4 plus 5. It has to be equal in order to multiply. They could also represent this by drawing a picture. So we have 4 in each group. And I do like to see them subitize, which means that they put them in an order kind of like on dice, to where if they just glance at it, it looks like 4. So this, we know this as 4. And that's what I prefer to do. Obviously, I'm not going to hold them accountable for that. If something else works better for them, that's fine as well. So if we just simply added these up, we should be able to get the answer. And the way that I do that is 4 plus 4 is 8, plus 4 plus 4 is 8, plus 4, and then we combine those, which is 16. 16 plus 4 equals 20. We could also add up the dots. The other thing we do is an array, and we use lots of manipulatives for this. So I'm going to do 5 groups with 4 in each group. So I'm doing 5 rows with 4 in each row. So I have 5 rows and I have 4 in each row. And we put the multiplication sign at the top. And when we first started, we drew lines in between so we could see the rows. Here's row 1, row 2, row 3, row 4, row 5. You're not necessarily going to see that anymore because we've moved on from that. Once again, from this model, they could just count. 1, 2, 3, 4, 5, 6, 7, 8. They can go all the way down. They can count by skip counting 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. They can skip count by 5s. 5, 10, 15, 20. So they're going to get the same answer regardless. And this is why I like them working with manipulatives. When we're talking area model, this is what they're going to see when we start moving to 2-digit multiplication and division. And they're going to see this all the way through 4th grade, I know for sure. So if we say 5 times 4, this is the same as this array model. It's just we're not having the individual objects laid out. This is representing the array. This is the area of the array. We're not using this in order to measure area and perimeter per se, but this is preparing them for that. So what they can think, and we do this on grid paper, what they can think is that we've got the 5 rows and there's 4 in each row. So if we wanted, we could even break this up and say this is 2 plus 2, because we can skip count by 2s easily. So if I say 5 times 2 equals, there's 5 times 2, plus 5 times 2, make that easier. This is 10, and this is 10, and then we add these together, and we get 20. The area model is new to them this year, but this is something that we're going to be talking about all year. They're going to see models of this. They're going to be seeing representations of this. Finally, we have the number line. This is my personal favorite just because I'm very visual. So I'm going to make 5 leaps. They're going to be equal leaps. 1, 2, 3, 4, 5. And I'm not so big into are they exactly the same size as much as I am each leap is 4. So 0 plus 4 is 4. 4 plus 4 is 8. 8 plus 4 is 12. 12 plus 4 is 16. 16 plus 4 is 20. And that gives us our answer. So we could very safely write our answer up here. We are not doing the standard algorithm yet. We will get into it. If this is one way that they choose to justify their answers, they can. But we are wanting to see one of these other models, because if they don't get this correct, I need to see another way that they do get it correct. This is a lot of memorization, whereas this is very concrete, opposed to being abstract. There's nothing wrong with the algorithm, but this is just one way to solve it. This is not the traditional way that we are teaching them to solve it. This is actually working for our students a lot better so far than this, only because this is how they've been learning. This is very similar to those models that they learned with addition and subtraction. I will be showing division in a later video, but I did want to show you these multiplication representations. You're welcome to watch this. You're welcome to pause it and do whatever you need to help your child. Thanks a bunch.